Okay, so this is Couchbase 101, our first presentation in our training series. We have 5 webinars in our training series. This one covers architecture, installation, and configuration, as well as the monitoring and graphs, so you understand how Couchbase works and what you're looking at when you're monitoring Couchbase. We like to really emphasize understanding how Couchbase works because it helps you to configure and program with a little bit more knowledge as to what it is that you're doing, what it is you're looking at when you're looking at your Couchbase server and on all the administration graphs, etc. So this is the Couchbase 101 where we talk through all those things that you're going to be looking at so you understand how Couchbase works under the hood. We will stop for questions. There are a few demos, installation demos as well, and a load test so we can talk about some of the graphs that we're looking at. As usual, you can always reach me at justdeep@couchbase.com and on Twitter at Scalable. And let's get started. This is a very full presentation, so there's a lot of material. And we will stop for questions along the way. So the first thing to cover is the architecture. And Couchbase is an evolution of memcached, and I think that this is important to understand because it helps you, if you've used memcached, Couchbase is going to be very familiar. The founders, the founders were key contributors to memcached back in the early 2000s. And they basically created a product called Membase, which was an evolution of memcached into a distributed and persistent key value store. So memcached was created as a way to improve on the performance and reduce the number of queries on SQL databases or relational databases. Relational databases were the only databases for about 30 some years, and in the early 2000s. In late 90s and early 2000s, as the internet became more prevalent and having online applications instead of desktop applications, what was happening was that relational databases, while they were very good in desktop applications, were having trouble keeping up with the audience sizes and unpredictability of audiences in online applications in the early 2000s. So when we also added additional devices, mobile devices, etc., and having applications that are both browser-based and mobile-based, these audiences grew even faster. And as we all know, it's grown to today where a certain individual might have 3 different devices, connecting to the same application. So audience sizes have grown, and what happened was relational databases really couldn't keep up with that growth and with those unpredictable audiences. And Membase was created to kind of improve on that performance, and that evolved into Couchbase. So Couchbase is an evolution of Membase, where the founders of CouchDB joined with the Membase crew to create Couchbase, and we added a number of new features, JSON support and MapReduce indexes, Elasticsearch integration, and our cross-data center replication. Of course, we're continuing to add more features, and we follow some core principles, and these core principles, are very important at Couchbase. Easy scalability is very important. I'm going to give a demo later about showing how easy we scale. Consistent high performance, the sub-millisecond read and write response times, always on 24/365, meaning we don't have to take Couchbase down to make changes or upgrades. And our flexible data model is, particularly useful and practical for, developers, especially in modern-day developers that are integrating with third-party services, using, retrieving JSON. Being able to store JSON is, very powerful. And it also very flexible. It allows for agile development and, changing of your, application model. Dynamically and being able to be very flexible. So Couchbase is, the architecture is made up of 2 different parts, a data manager and a cluster manager. Each Couchbase node in a Couchbase cluster runs the same software, so we don't have specialized software for different nodes. They actually all run the same software, the Couchbase server. This actually makes deployment much easier because you don't have to orchestrate many different types of nodes. There is a number of ports that we are using. We are still backwards compatible with memcached. And that's the 11.2.11 port that anyone who uses memcached is familiar with. And then our own SDKs actually use 11.2.10 to connect. Our querying API, for views is 8092, and then our cluster administration, our monitoring is on HTTP port 8091. And then within the cluster communication, we have a number of ports for inter-cluster communication between the nodes. The data manager is made up of a RAM cache, the indexing and persistence management, and that's all written in C. And then the server and cluster management and communication and monitoring is all in Erlang. And so we have a number of Erlang ports open between the nodes in the cluster. Hold on one second. GoToMeeting keeps popping up and making it so I can't go to the next slide. Very annoying. Okay, let's get back. Thank you. So Couchbase is organized like a key value store. It is a documents, database, and it's organized like a key value store. So similar to a hash table or a dictionary. Each key is a string up to 256 bytes, completely up to the application programmer as to what the keys are. The values can be simple data types, all the things that you would expect: strings, numbers, datetime, booleans. And then you can also store complex data types, dictionaries and hashes and arrays and lists. And that's because we store in JSON format. And JSON is, just a special class of string, for encoding simple and complex data structures. This is one of the main differences between relational databases and Couchbase, is that, being able to store JSON allows us to actually store complex data types in a single document, rather than having to normalize complex data types into multiple tables. Schema is unenforced and implicit. What that means is that Couchbase server itself does not enforce a schema. It's implicit in that your application model creates a schema implicitly when you have your strings and numbers and complex data types in your objects, and you serialize it into JSON. There's an implicit schema there. Now, schema changes can be done programmatically, done online, meaning we don't have to take Couchbase server down, and they can vary from document to document. So unlike tables where every row has to have identical columns, documents can vary from document to document. So you can have optional fields, that show up in one document but that don't show up in another document. We are, so Couchbase, we store when we store documents, and just for the convenience, we're going to call everything a document, JSON documents, and also simple strings or numbers as values. We're going to just call them all documents. So in Couchbase, we have basically two different parts. We have metadata about each document. And the metadata is kept in RAM at all times. It includes the key, which is the meta ID, and then it includes some other information: the type, the expiration, flags, and revision numbers. The flags and revision numbers are used by internal to Couchbase or the SDK, and generally not things that you need to be concerned about. The ID is the key, and then the value is the actual document. So the value, the most recent, is kept in RAM, or if you've sized appropriately, all your document values are in RAM. And of course, those are also persisted to disk. So we have metadata and we have document data. So the metadata is, like I said, is kept in RAM at all times. This makes operations very quick in terms of determining whether a key exists or doesn't exist, as well as expiration. So retrieval operations. In this case, we're doing a get operation, which is a retrieval, and that's going to come right out of the RAM cache. The storage operations, when you do a storage operations, in this case we have set, add, and replace or storage operations. What they do is they first go into the RAM cache, then they get put into a disk write queue and a replication queue. So we decouple the slowest component of any server, which is the disk, from our our data serving. So we have a RAM cache in front, which is very similar to what we were doing with memcached in the early 2000s in front of relational databases. Basically, you don't want to go to disk all the time because disk is slow. So what we've done is we've decoupled our disk writing from our RAM cache. And so whenever you do a storage operation, it goes into RAM cache first, then it gets put into a disk write queue and a replication queue, and then we have I/O writers writing those to disk, and also across the wire we're transmitting those documents to replicas for failover. So what we have here is we're doing an operation that goes to RAM cache first, then disk write queue, then to disk. So we are a consistent database, not an eventually consistent database. When you do a storage operation, you can immediately read that that value, even though it's been put into the disk write queue. Let's do that again. Even though it's been written, it goes to the disk write queue, and you can immediately though read your own writes. So we are a consistent database. And this is a little bit different than other NoSQL databases that are eventually consistent, where you can actually retrieve multiple versions of the same value, and then you have to have logic to resolve which one is the correct one or the most recent one. So you have to actually write that resolution logic in other NoSQL databases that are eventually consistent. We are a consistent database. So what happens if your RAM cache is full? Now, if you don't size your cluster to contain all document values within RAM, we basically have two watermarks based on the RAM cache allocated. We have a low and high watermark. When you're at 90% full, what we start doing is ejecting document values from RAM. First, what we do is eject replica values, and then we eject active values. So what happens is when you do a get on something that has been ejected, and we use an NRU, which is a not recently used list, it reads it off disk and then into the RAM cache, and then returns it to your application server. So in a cache miss, this is what we call a cache miss, it'll read it off disk into RAM cache and return it to the application server. So now that one is a recently used item, so it is in the RAM cache now. So that's what happens, when you reach that sort of threshold of RAM. At 90% we start, ejecting from the RAM cache onto disk. So those reads will come off disk, so they're a little bit more, they have a little bit more latency than coming straight from RAM cache. Generally speaking, most customers actually size their cluster to contain all their document values in RAM. So this is not as common, but there are people that don't want to size that way, and so this is important information to understand what happens. So our clients actually connect directly to Couchbase nodes. They don't go through a sort of a routing server. They connect directly to each node. So we have basically what we call a map, a cluster map of partitions, and we basically break up all the data in 1024 partitions on disk and in RAM. So we have these partitions that get redistributed across servers when you add new nodes to the server. So we have a map of all these 1024 partitions and where they live in the cluster. Right now, there's only one node of Couchbase, so all 1024 partitions are on that one Couchbase node. When clients connect to the Couchbase cluster, in this case it's just one node, they actually retrieve that map, so they know exactly where which partitions live on which server. Now, this is also leads into, well, how do we distribute our data across, how do we distribute our data in Couchbase? So we use basically hash partitioning on the key. So hash partitioning, it's a CRC32 hash, and it's a very simple hash, and what it does is take the key, it's a key value, So we take the key, we do a hash on that key, and we get a number from 0 to 1023. Then we look at the cluster map and see which node of Couchbase we should be going to for CRUD operations on that key. Where do we store or retrieve that value from? And then we go directly to that node. The client SDK manages this all within the client. It's taken care of. It'll go directly to that Couchbase node to do CRUD operations for that item. So we hash the key, we get a partition number, we look at the cluster map for that partition number, and we go directly to the IP address responsible for that and do CRUD operations directly with that node. So we have 1024 partitions. In this case, we have 3 I/O workers configured, and we have 8 gigs of RAM. So let's look at what happens when you add more nodes to the cluster. So in this case, we're going to add just one more node to the cluster, and we do what's called a rebalance operation. And what we're doing is moving these partitions. These partitions contain, many values, a whole collections of documents, and we're moving half of the partitions over to the second node. So what we've done is, now doubled our capacity. We now have, we still have 1024 total partitions, and we have 6 I/O workers now and 16 gigs of RAM. So when we want to double that again, we're going to add 2 more nodes to the cluster, and what we're going to do here is rebalance again, and we're going to move again, partitions over, and now we're evenly distributed again with these partitions. The cluster map gets updated, and then the clients will update their cluster map as well. And so now we've doubled our capacity again, doing 12 I/O workers and 32 gigs of RAM. So this is basically sort of how Couchbase works. So we hash keys into a partition, and then when we want to scale horizontally, we are basically redistributing the partitions, and we keep track of these partitions in a cluster map, and that cluster map is also kept track of, on the client side. So basically, through our persistent connections to Couchbase, we can update that cluster map. Inevitably, people ask, well, can I have more than 1024 partitions? Does that limit me to only 1,024 Couchbase servers? Actually, very large clusters for our enterprise customers usually have between 40 and 50 nodes of Couchbase. So the number of partitions is sort of irrelevant. The reason why we do this is to abstract a layer where in our cluster map, we actually are not creating a map of every document and where every document lives within Couchbase. This is just an abstraction, a layer in between, where we basically hash into a partition, which is a group of data, and then we can move entire groups of data around within the cluster. And then our cluster map is quite small. There's 1024 entries in that cluster map, and it was a decision made years ago that has worked really well. These 1024 partitions actually works quite well. So this is how we scale horizontally, and I'll give a rebalance demo later in the presentation. So our guidelines for RAM, CPU, and I/O. So RAM is used, obviously, all metadata, and actually we've reduced it from 64 bytes to 57 in the latest release. So there's 57 bytes per document as metadata. And then there's the actual key length adds to that 57 bytes. And so that is all, the metadata is the 57 bytes plus the key length, and all of that must reside in RAM for all documents. And then there's the document values. The rest of the RAM will be used for document values. And we also leave RAM for the operating system. So we don't configure Couchbase to use 100% of available RAM. We leave RAM for the OS for file system cache, more specifically for views, because views come off disk, and so we want file system cache to improve performance of view querying by leaving more RAM for the operating system for views. The CPU is used for document indexing, obviously the Couchbase monitoring itself, and cross data center replication. We have some, sort of minimum recommendations of having 4 cores and then 1 core per design document. That's basically per indexer. for secondary indexes, and 1 core extra for each bucket that's going to be replicated through cross-data center replication. Our disk I/O is obviously all persisted documents, and then it's all our indexes as well for design documents and views, all our secondary indexes, and we use an append-only disk format, so that this actually improves our performance considerably because we don't have to rewrite, we just append only, and during compaction we rebalance those files, and we do online compaction, so we compact our disk files while Couchbase server is running. And we have certain thresholds that we can set within Couchbase, the admin. We have thresholds we can set in terms of what we call fragmentation levels, where we begin that online compaction. We can also schedule it so it doesn't compact during certain hours of the day. And for performance, as an example, if you want to increase your disk I/O performance, if you're on Amazon, having multiple EBS volumes, with high IOPS on a RAID 0, is one example of improving performance for disk I/O. So, on Amazon, disk I/O is also related to network, especially with EBS volumes. So having multiple EBS volumes, will increase that throughput. Of course, they offer the high IOPS as well. Okay, so it's doing it again. 1 second. I don't know why it does that. All right. Have to periodically leave and come back. Okay, so our binary operations are on port 11, 210, and 11. Of course, we are still backwards compatible with memcached, and that's one upgrade path for people using memcached. You can actually just swap in Couchbase for your memcached installation, and then migrate your relational database over to Couchbase, using Couchbase as your primary store. But all these operations, if you use memcached, set, add, and replace for storage. We have atomic counters in Couchbase, which is a great and relatively unique feature of Couchbase in the NoSQL space. Is these atomic counters are used for key patterns and all kinds of interesting things that are very powerful. So we have increment and decrement, and then we have our optimistic concurrency, with compare and swap, our CAS operation, which is related to storage. Basically, optimistic concurrency means that we, if this document has not changed since my last retrieval, do this operation. So CAS value is basically a long integer, and every time we do a storage operation of any type, it creates a random large integer that represents the current state of that document. We have HTTP operations. Those are on port 8092, and that is for our view querying. Of course, we have a lot of different types of view querying. We cover that in Couchbase 104, range queries and index key matches and set matches. And that's all on port 8092, and that's HTTP. So I'm going to stop for a second to answer any questions that have come up, and then we're going to kind of cover the installation of Couchbase.
Thank you, Jasdeep. Yeah, we have a lot of questions coming in, so let's start with a few now. So the first one is about the type of files that you can store on Couchbase. For example, can you store MP3 or audio or video files, or can you store XML documents file?
Well, so XML is just a string, so of course. And yes, you can store binary data with Couchbase, no problem. MP3s, JPEGs. I wouldn't necessarily store videos. I mean, we do have a 20 megabyte limit for, I guess if they're very short videos or small videos. Generally speaking, for things like videos, there are other solutions that are, more optimized for video for streaming. But, for JPEGs, MP3s, things like that, one of the advantages of storing in Couchbase is coming out of RAM. So you're going to have very high performance. Even S3 is not coming out of RAM. So sometimes you can use this to increase your performance of delivering assets.
Perfect. Thank you, Jasdeep. Another question is about sizing, basically. So how much RAM would you leave for the operating system, or do you have any recommendation for the amount of RAM to use for the front end and back end?
Well, we do have a great blog post, which I can, if you remind me, Franco, to include in the follow-up email for sizing, where we cover, we actually have a video from our San Fran Couchbase conference, last September, where we talk about sizing. I mean, there's a lot of things we could talk about. That's actually kind of a long question. But generally speaking, most people size their clusters, and I do too, so that I have all my document values in RAM. But that is optional. But then you also have to understand a few things about, cache misses, etc. when you have very high write speed, and we'll talk a little bit about that as well.
Perfect. Another interesting question here is, so if you have the clients that connect to Couchbase server, and you have, for example, a cluster of 10 servers, to which of the servers should the client connect for the initial request?
Generally speaking, you should put a list, at least 2 to 3 servers. They all have the same, cluster map, so you can connect to any of them. And it's just a good practice to when you in your application to actually have multiple nodes in that list, so that if you have let's just say you don't update your application code for quite some time, you want to make sure that all the nodes, all the IP addresses that you're providing in your application to connect to exist still. Like if you've done upgrades and you've changed IPs because you've done rolling upgrades to the next Couchbase version, or etc., you're going to be changing IPs, and so you're going to want to make sure you have multiple in there. Of course, there's a little bit more sophisticated where you use your own internal DNS. So even if IPs change, you have this list of addresses to connect to if you're using a VPC or something like that. Perfect.
And the last question is, so is Couchbase available also for Windows? This is easy answer.
Yes.
Yes. And we will see a demo at the end as well.
Yeah.
So with this, let's resume the presentation, and we'll have more time at the end to cover additional questions.
Yeah, and we'll stay past the hour for additional questions. It's no problem. Okay, so installation of Couchbase. Of course, you can download Couchbase first at www.couchbase.com/download. And we do actually have, if you're familiar with Homebrew, you can do a Brewcask install on Mac. But generally speaking, we recommend installing the Enterprise Edition because it is free for up to 2 nodes in production, and of course on your laptops, etc. You can use it for free, no problem. We do have a Community Edition as well that's pretty standard, open source, that we have it a little bit further behind from the Enterprise Edition. The Enterprise Edition is the most heavily tested, and I do recommend you use the Enterprise Edition when you're playing around. So couchbase.com/download. The install instructions are right next to the logos there. For Red Hat, there is a dependency, and there was a question earlier on, and it actually has to do with the Erlang core. Has a dependency on an older libcrypto. And if you need that, you can just kind of Google the libcrypto and Couchbase, and you can see the yum install 098 OpenSSL 098E. So that's important to understand just for Red Hat. But we do support Windows and Mac and Ubuntu. Pretty easy installs, and I'll be doing some. We also actually have an Amazon AMI. If you do the Amazon Marketplace and you search for Couchbase, you'll see there's 4 different ones here. The Enterprise Standard and Enterprise Premium include our support contract in the pricing. Then there's Enterprise Free, and then there's also one for our Couchbase server with Sync Gateway. That's for our Couchbase Mobile, and there's an upcoming webinar this Friday on that. So you can also install with AMI, and I'll demo that later. Okay, so yeah, you search for Couchbase, and if you're just you don't want the support contract built into the pricing yet, you can just use Enterprise Free. So when you install Couchbase, to finish up the installation, so like on Mac you would drag it to your applications folder, on Windows you double click, and then you need to navigate to port 8091, which is our administration port, or if you did it on the AMI, it's the EC2, the public address with port 8091. This is the first screen you're going to see is set up. And this is pretty much the first step here is your disk storage paths, and also this is a little bit more important to understand at the bottom is this is your per server RAM quota. This is actually sort of the maximum memory allocated to Couchbase. You actually can do a bucket level RAM quota as well. So what I don't recommend is setting this value very low, because you have to actually use the CLI, the command line interface, to change this value. But you won't actually be using this much RAM unless you fill it up with this much data, and also that the buckets have been configured to use this RAM quota. The RAM quota default is about 60% of available RAM, to leave RAM for the file system cache, the OS file system cache. So this value, I generally just leave the recommendation myself. I think it's fine. And then if I want to use less memory, on my laptop, for data, which, it'll only use it if it fills it, I'll configure my bucket to be smaller, and I'll show you that. So generally speaking, I would leave this value alone. And then there's options to install sample buckets. We do have some sample applications that are related to the beer sample. If you check that box, it'll set it up. You can also do it later. The reason they ask now is because the default for the default bucket is to use all the RAM available in your per server RAM quota in that first step. So, and this is basically configuring the default bucket. The default bucket, it's going to say it's going to actually default to, the RAM quota. And in this case, I can actually lower it. If I, just want to have a small bucket, I do 300 megabytes, and it'll only use that 300 megabytes. Or you do, 1024 or 248 or whatever it is. And you can also configure the number of I/O workers. And in this case, we default to 3, and you can have up to 8. And then at the bottom, on the left bottom there, you can see flush. In the administration interface, we enable and disable what's called flush, and that's basically deleting all data from programmatically from the SDK. If you do a cb.flush, we can disable it here so that if you're in production, you can't actually call a flush command. So if you're doing your sort of testing, etc., you want to enable flush so that you can actually run your tests. And and then you can also disable it in production. So we put that in there just to have prevent someone running tests in production that actually flush the database. And then the next step is product registration. If you put your email address in here, you'll get our newsletter, which is very infrequent, but has really good information. And then, of course, here's the password to the administration interface. And this is something that you should make sure you remember. Do an easy one, especially on your own laptop. This is not that important. I'd be more worried about someone breaking into your laptop than getting into Couchbase. And I do ASDF myself for my password on my laptop. If you do forget it, you can Google for forgotten password, Couchbase console, and see if you can, there's a command line command that you can run to retrieve that password. But I do recommend just doing something easy to remember and simple for this. And that's it. Then your setup is complete. And we're going to actually, I'm going to show you a demo of that stuff as well. So we do support a lot of SDKs, Java, .NET, PHP, Ruby, Python, C, and Node.js. We do have some other clients as well for Clojure, Erlang, Go, and Tickle, Perl. And to find those, you go to the couchbase.com/communities, and you can see all the different supported SDKs. And then on the left for other community clients, if you click on all clients on the left nav, and scroll down, you see all the different clients for other languages. They're called community clients, but some of them are actually made by Couchbase folks. because they're not officially supported with our support contract, but they are available, and of course, we use a lot of them all the time. The Ruby, PHP, and Python clients are wrappers around the C library, so you need to install libcouchbase first before installing those three. The Node.js one most recently actually includes the libcouchbase in the npm install. Just for PHP, Ruby, and Python clients, you're going to need to install libcouchbase first. So installing libcouchbase for Mac, I do recommend Homebrew, and so in order to do that, you have to have Xcode and the command line tools installed. And then, of course, if you have Homebrew, it's always good to do a brew update and upgrade and doctor to make sure you're up to date. And then you can just do basically a brew install libcouchbase. For PC and Windows, go to the couchbase.com/communities/c/getting started, and there's instructions for installing the C library. For PC and Windows, you download the appropriate zip file based on your Windows version and Visual Studio version. And then, of course, as typical with Red Hat and Ubuntu and CentOS, you get the repository first, and then you do a sudo yum install or apt-get install, and all the instructions are on the web page there. And we do cover more of this in the operations, SDK operations webinar coming up this Thursday in Couchbase 102. Let's move. So in terms of server monitoring, let's go through a lot of the stuff that you see when you click on Couchbase. In the administration interface, you click on a data bucket, you're going to see this wonderful UI with a lot of graphs. Of course, when you first click on it, after install, it's going to be pretty flat, but because you're not doing anything yet. Let's kind of go through sort of these graphs. So the first two rows here are your total operations per second, how many cache misses and retrievals off disk you have, your retrieval operations per second, your storage operations per second, the delete operations per second, your compare and swap operations per second, and then the percent of your documents that are in RAM and resident. This means all your if it's 100%, this means all your document values are in RAM, and then your item count for the number of documents you have. The next row is I need to explain a little bit. This temporary out of memory per second. What this means is when you reach that sort of threshold. So we have these two watermarks based on our configuration of RAM for this bucket. If you have your RAM is full and it is ejecting, but you have very high velocity writes at the same time, so it's trying to eject values to disk, and it has a lot of writes happening at the same time, and it's exceeding the capacity of being able to eject. So you're writing faster to Couchbase than you are able to eject from your full RAM. You will get a temporary out of memory error message in your client, which basically means back off on your writing, and you can handle that at the application layer. Generally speaking, if you size your cluster to handle values, having all values in RAM, you're not going to run into this. Or if you've scaled horizontally, you may not run into this either, because your ejection capacity, your ability to eject from RAM, is increased because you've increased your disk I/O as you scale horizontally. So we have these two watermarks, the low and high watermark, and basically when you reach the low watermark of memory used, it'll start ejecting replicas from RAM, and then when you get to the high watermark, it'll start ejecting active values from RAM. So active values, active partition document values versus replica partition document values. And then at the last column is the RAM and data, RAM used for metadata and data combined. Okay. Then the next two rows are all about the disk, and this is your sort of creations per second, your updates per second, your disk reads, and your disk queue size. So your disk write queue, and we're keeping track of the size there. And then we also have the compressed data size, the uncompressed data size, and then your fragmentation level. So fragmentation is just from writing with our append-only format, we keep track of the sort of fragmentation of those files, and then at a certain threshold that is configurable, we'll compact it, and that's why you see that sort of patterned graph where it goes up and then down and then up and then down. This will also change your document data size because during that compaction, we will also compress on disk. And then there's the total disk usage at the end there. And then, and so when you're looking at this disk queue size, disk write queue, you're looking at this pattern where it's increasing then draining to disk, increasing, draining to disk, and then. But if you see something that is more like this, then this is an indication that you need more disk I/O capacity, where your disk write queue is just growing and growing and growing. It could indicate that you also have problems with your disk, or it could be just that you don't have enough capacity based on the velocity of writes that you have. And then the partition details, that's the next sort of section below. We actually keep track of all the information by partition as well. And so in this case, we have active partitions, we have replica partitions, we have pending partitions, which will show up during a rebalance, and then of course the totals. And then for each of these, we have the item count, the percent residency, how fast you're creating new items, and then once you reach that low watermark or high watermark, you're going to see these ejections. And the high watermark will be in the active, and the low watermark will be in the replica column. And then the amount of user data in RAM, the documents, and the amount of just metadata in RAM. So we have all this for the active partitions, for the replica partitions, for pending, and of course the total. So on Mac, because the default, this is just important because we did talk about having 1024 partitions, but on Mac, because there's a default file descriptor limit is low, we actually only do 64 partitions on Mac. This doesn't generally matter at all, especially for your local applications, but it does matter with cross data center replication between Mac and other operating systems, because the number of virtual buckets or partitions have to match because we replicate from partition to partition. So don't try to do XDCR between your Mac and other operating systems. Yeah, it won't work properly. And you can actually change that to 1024, but you have to increase your file descriptor limits in order to do that. So then the next section down, the next major section down, is specifically for your disk queues, where you have, you can look at details in your disk queues, and again, it's also for active, replica, and pending. So we have your queue size, then we have the rate at which you're filling the queue, and the rate at which you're draining the queue. So this is also good information to understand what's happening with your disk and your capacity. And then that last one is sort of the average age of how long those queue items, stay in the queue. And generally speaking, this is, if anything, it's in the thousands place unless you have an I/O issue, or 10,000s or 100,000s place. I should be able to give a demo where I actually exceed my capacity a little bit, so I can see some age there. So that's the average age of the queue items, how long they live within the queue. All right, so we're going to get to the demo, and I'm going to do my Amazon stuff first, okay, and then I'll do my local computer. So I actually have a cluster up. So here's a cluster on Amazon, and I actually have a number of servers, and what I'm going to do is add more servers to this this cluster. I have 3 right now. And oops, need my stickies. I'm going to add 3 nodes to that cluster. I've already configured these. We use a little right scale just for our demos because we can spin up a whole bunch of Couchbase servers really easy. So here I'm going to add an IP address for a 4th server, and then I'm going to do a 5th server. And this is how easy it is. and it's warning me that it's going to delete all the data on those target servers, and then 3. Add another server here. All right. And now, so I've added basically 3 servers to the cluster, and it's not going to start redistributing the data until I hit rebalance. When I do a rebalance here, it is now adding those to the cluster, and let me show you. Let's go to this and go to the vbuckets, and as you can see, let me zoom in a little bit. As you can see that these are basically starting to migrate over, right? And you know, it's currently doing this rebalance, and you're going to start, you're seeing, let me collapse these other ones. You're seeing it basically is starting to migrate those over. And let me pick actually one of the original nodes here. You can see it's moving vbuckets over, you know, active vbuckets and, you know, replica, and you can see that sort of pending. So, wow, that rebalance is being so fast. So this one is increasing. This is one of the target servers. It's increasing, and it's basically going to be, I think it's almost done. Unfortunately, this was so fast that, like, basically it's moved all these partitions over, and now we're done. So that was really quick. So now I just doubled my capacity from 3 servers to 6 servers. And I can also remove servers from the cluster very easily. So let's go ahead and remove this. And it's pending removal. And basically, when I do a rebalance, it's going to redistribute and move over whatever active and replica partitions were on that server and move it to the, redistribute it to the other 5. So that's basically how we scale horizontally. This is how we you know, add nodes to the server and remove nodes from, add nodes to the cluster and remove nodes from the cluster. All right, and I'll also do an AMI installation. So let's go to the marketplace, Couchbase. We'll do enterprise free. We'll do it on the large. I'm going to go through this a little bit because I want to also delete the volume on termination. All right. And I'm going to launch this. Oh, I know. And just so you know, there's usage instructions, so it automatically configures the instance ID as the administration password. So let's go ahead and go there. And when that's done, I'll come back. So it's pending right now. All right, so on my local Mac, I already dragged it to my applications folder, so I'm going to do an, oh, it's not running. Couchbase server. All right, so here I'm going to do the setup, and like I was saying before, I'm going to actually leave that per server RAM quota. Now, every node of Couchbase is going to have the same amount of RAM associated with it. So, in terms of capacity, it's good to have the same level of capacity on each node of the cluster. So if you have, let's just say 2 nodes of 8 gigabytes, and then you want to actually have, you know, add a node that has 16 gigabytes of RAM, what you have to do is actually swap, do a swap in of nodes that, machines that have 16 gigs to replace the 8 gig machines. And then on the CLI, you can change this capacity and increase the capacity of the whole cluster. So that's how you would do it if you want to increase vertically on each node of the cluster. But here I'm going to go through this quickly. I don't need this, but I'll just do it anyway. I'll do this. And I need to enable flush. I'm going to do a little load test here. I don't need this for my demo. All right. So now it's getting set up and loading the beater sample database, etc. And while it's kind of finishing that, okay, so this instance is running. This is through the AMI. Let's go there. So, okay, so this is ready. So let's look at the default bucket here. Right now, I don't have anything going on, but I'm about to do a load test. So let's go. I have a load generator. I'm actually going to run this because I have 4 cores here. I'm going to run 4 because Ruby is single-threaded. And I want to generate a whole bunch of load. So I'm going to run this in 4 different terminals. And basically this load generator has 5 phases. First, all it does is create 100,000 items. I basically change the read and write percentages. I actually have it open here. I go from 100% write to 33% read to 33% read again to 60% read and then 100% read. So I kind of go through all the different phases, just creating items. So what you can see here is right now I'm in that first phase where I'm just doing heavy writing. I'm doing about 6,500 ops per second here, just creating data, and then we're going to see when it gets to the next phase. And each one of these threads is going to total. So right now we're still in that sort of creation phase. So let's look at that. Yeah, we're still in the creation phase, and you can see all the creations per second here. We can look at our disk queues. You can see sort of my drain rate, and you can see the sort of average age is almost 0 all the time, and then it's like the almost 100,000th place occasionally. This is our fill and drain rate. You can see how fast my draining my disk queues. We can also see sort of my updates per second, my total operations per second, amount of memory used, the number of items. I should, by the time I get to about 400,000 items here, which I'm very close to, you're going to start seeing the ratio change. So that first thread is starting to change to a 33% read. You can kind of see now I've got get operations and create operations going at the same time. And you can also see sort of our vbucket rates. We can also see the number of items. I'm not going to hit any ejections here because I have enough RAM, but you can also see the number of user data in RAM and then the amount of metadata in RAM as well. So this is kind of a nice way of seeing what's going on with Couchbase. So let's look at this AWS instance. Did I not get the right IP? Actually, Franco, while I'm figuring this out, I can answer some questions.
Yes, thank you, Justip. We have, again, a lot of questions, so let's
sure.
see how many we can answer now. And for those that we are not able to answer, Justip is really good in following up via email, and he also writes a blog with all the answers as well. So we will make sure that we answer all the questions by email or by blog. So let's start with one. Do we have to add all the IPs of the server manually, those servers that we add to the cluster?
Oh, definitely not. You can script it. Oh, I was doing the wrong IP. So this is my AMI is up. No, you can script it. Everything is scripted, including all this information in this console. The admin console is actually JSON. You can retrieve this from port 8091. If you look at the view source, you can see the Ajax request that is pulling all this data. So you can do things through the command line as well. You can add nodes to the cluster automatically, add new nodes to the cluster, remove, rebalance, etc., all through the command line. And then also, if you want to, attach some of this monitoring to another system that can, use JSON, you can do that as well.
So what about compaction? Is there automatic? Do we have to do manually, and how often do we have to do it?
It's all automatic. So this is my AMI is complete. It's all automatic actually, and you can see it. You should see it happening. My fragmentation levels, and it's configurable here in the auto compaction. At which point that you do compaction. It's a percentage of fragmentation here. It's the same for view fragmentation, and we can also make sure that it does not happen during certain intervals. Like a peak, you don't necessarily, if you don't want that. Of course, when you're doing compaction, it's additional disk I/O, to do that compaction. So if you don't want it to do that compaction during peak times, you can make sure that it, basically, doesn't happen during a specific time, or you basically specify the times at which it can happen. And you can also parallelize your database and view compaction at the same time as well. So there's a number of configuration parameters here for auto compaction.
Perfect. So what about replicas? How many can you set up, and how many do you recommend?
Well, most people just do one replica. Of course, when you add replicas to the system, you're also increasing the resources required, right? So if you're going to have 2 replicas or 3 replicas, in order to have high performance, you need to vertically scale those servers to have enough RAM to have those replicas in RAM as well, in order to have, a faster failover scenario. And also with indexes, so indexes are on disk on each node of the cluster. Since your data is distributed, our secondary indexes will be indexing on each node of the cluster. Now, if you want to also index the replicas as well, that increases the CPU requirements. So if you have more than one replica, you're going to have additional requirements as far as scaling your servers vertically to be able to fail over quickly and also have all the data indexed in the replica as well. So generally speaking, I have not heard of too many customer deployments that have more than one replica. But if that is sort of a requirement, for you, then you understand that you'll be needing beefier machines to handle multiple replicas.
Perfect. So what happens if a node crashes while the cluster is rebalancing?
During a rebalance, so basically the rebalance fails, right? And so you'll have to reinitiate the rebalance, and you probably have to fail over that node. Fail over that node in the cluster, and then do a rebalance. And in which case, you probably want to do what's called a swap rebalance, where you're going to add a node to the cluster at the same time that you fail over. So that actually makes things, faster in terms of rebalance, because you're basically replacing a node, and we don't have to we don't recalculate which partitions go on which node when you do a swap rebalance, because there'll be the same number of nodes in the cluster. As before. So you might want to basically, or in that case, if you're failing over, you can do the rebalance operation where you add 2 nodes and fail over at the same time. That way you're increasing capacity at the same time as failing over. So in that rebalance operation, I can, let me go back to this scenario. I can, let's see, which one isn't added? I can show you. I can do both at the same time. So I took out 240. I'm going to fail over 169 because let's just say it's failed, and I'm going to also add this at the same time. And I'm going to do a rebalance. Okay. This is my local host. Still going. Oh, now I'm at 100% read now. Oh no, I'm at 60% read and 30% write.
We had quite a few questions about that 20 megabyte limit on the document side. Can you clarify better on, for, of course, users are asking, how do you do with files that are larger than 20 megabyte? Like if I have a PDF presentation of 40 megabyte, or how can I configure my cluster and application to deal with this type of files?
Well, this happens actually all the time. I mean, this is one of those scenarios where you have large assets, in which case you should keep track of sort of metadata of that asset within Couchbase and not necessarily store the actual PDF there. You can store the PDF in S3, for instance, or with CloudFront, or you can store it with any number of CDN type systems. Where you're all those large assets are stored somewhere else, but then you have the links to that within Couchbase. Where you're pulling it off of S3 or CDN. I mean, and this is how you deal with things. Pretty much in every scenario, you wouldn't store that PDF in a relational database either. So you'd be using this sort of similar sort of strategy, with Couchbase as you would, a relational database. In terms of like large assets, you wouldn't necessarily store them directly in your database.
Perfect. Great. We have time for two more questions. One is from Giacomo, and he's asking about, so you said to set the high memory level when you set up Couchbase, but can you start little and start with a lower limit of memory?
Of course. So I mean, if you want to, so there was the per RAM quota, per node quota. That's what you set up in that very first step. That's going to be the total amount of RAM available to Couchbase, like the total available to Couchbase, period. Then within each data bucket, you can actually, change these settings. So in this case, I set my default to only use 2 gigs max, and it'll only be able to use 2 gigs max. And I can change this dynamically. I'm going to watch. I'll just change it to. Oh, well, I can't change it to less than what I'm currently using at the moment because it'll cause ejection. So, but I can lower it. What is my current? Oh, it's 1.46. So I can't lower it dynamically right now than what I'm currently using. But you can set it to whatever you want. I mean, I can set it to 100 megabytes if I want. Let me create a new one, because it's currently active right now. So test bucket, and I'll just set it to 100 megabytes. I mean, it's basically also understanding what you're doing when you're setting it up, and you're going to have a lot of ejections in this case. So I can actually show you, while I answer questions, what I'll do is, as soon as this load test is done, I'll delete all the data in there, and then I'll run the load test on a 100 megabyte bucket so you can kind of see what happens. Because there's going to be a lot of ejections, and I'm going to hit that temporary out of memory because my write velocity is going to exceed my ability to eject if I set it to only 100 megabytes. And it'll happen pretty quickly, actually, because I'll have 4 processes trying to write data, 100% write load. And I won't be able to eject fast enough from a 100 megabyte bucket. So yeah, I mean, I hope that answers your question. If not, you can always email me, and let me put that information back up. You can always email me.
For any other question, you can also email webinar@couchbase.com, and
right.
I will pass all the questions to Jasdeep.
Yep.
We have time for one last question, and we apologize for going a little over time, but we are recording this presentation, so if you have to leave, you will be able to listen to this later.
Yeah.
So we have a question from Bo, who is already a user and using Couchbase in production, and the question is, we are using 2.0 in production. What's the best practice to upgrade to 2.2 if you have to do an upgrade of Couchbase?
If it's on your local laptop, you should be able to actually just upgrade in the by dragging your application over. If you're talking about like on AWS, doing a swap, basically add a second node to the cluster that has 2.2, and then do a rebalance. So now you've distributed on 2 nodes, and then remove the original node that from the cluster, and now you're basically back to one machine with 2.2 on it. So basically it's called a rolling upgrade. So if you have a number of nodes in your system, you can you would do this sort of rolling where you remove nodes and add nodes, and you can do obviously more than one at a time when you do that. But on your own local machine, it just depends if you need the data that's in there or not. You can just delete and reset and start it again, or it just depends.
Yeah, I think he was referring to a production cluster with more than 2 nodes.
Right, in which case you do a rolling upgrade where you basically create nodes with the 2.2 and rebalance them in, and then remove the ones with 2.0 from the cluster, and rebalance those out.
This is one of the features that users of Couchbase know very well, in terms of like that you can do any operation by maintaining the cluster online without having no downtime at any time for upgrade, maintenance, operation. This is all the time we have for today, unfortunately, but I want to remind everyone that on Thursday we will have Couchbase 102, which will be focused on SDK operations. Then on Friday, for those of you interested in mobile, we will have our first mobile training, which is called Couchbase Mobile 101. And then next week we will have 103 and 104, which are data modeling and indexing and queries. And the following week we will have our first Couchbase 105, entirely focused on XDCR and Elasticsearch. With this, I want to thank you all for attending today, and I want to thank you, Jasdeep, for the presentation. Again, we will follow up with all the questions that you sent today, and thank you again, and see you on Thursday.